If you have a Amana, Whirlpool, Maytag, or a similar brand made by Whirlpool dryer that will not heat, I'm going to show you how to diagnose and hopefully fix it today. This repair and how you tear it down to diagnose works for any single dryer that has the lint door right here. If it has this, then it is a Whirlpool made model. Also Kenmore's are Whirlpools that have this as well. So if your vent or lint trap looks like this, I will be able to help you pretty well. If it doesn't look like that, you can follow the same ideas and procedures that I will give you today, but it's going to be different on actually taking the unit apart. Almost regardless of model, these are the tools you'll be using to tear down the dryer to diagnose. This is a 6-in-1 screwdriver. It has a 1/4 inch and 5/16 drive on it, a multimeter from Amazon, a putty knife. Those are the three things you absolutely need, but I am going to make it easier on myself and use a drill gun to take the screws out and kind of speed this whole process up. We're going to be diagnosing all the heat components in this. The idea on this teardown is to find the component that is bad. So this is a working dryer, it heats up just fine. But the deal with it is if you find a component that doesn't return the results that my multimeter does, chances are it's bad and that is what needs replaced. So what we're going to do is plug it in and go from there. First thing we're going to do this unit before we open it up is going to test for voltage. To do this, you're going to need a multimeter. This again is one off of Amazon. It's an MSR C600. If they make them, I'm going to post it in the comments. This has worked really well for me. Step one is to look and see what kind of voltage we get on the unit. If we don't get voltage to the terminal block here, then any sort of diagnosis on the actual dryer is going to be, quite frankly, useless. So if we can't get 240 volts to this line, then our problem isn't with the dryer, it is with the power cord or the electricity itself. So we're going to change it again to volts, and we're going to test it and see if we can get 240 volts to the dryer. Once you have your multimeter set to voltage, you're going to take your positive and negative terminals and first test the first leg of electricity to the dryer to confirm that there's voltage. You should get 120 volts on the first leg. Next, use the multimeter to confirm that the right leg has 120 volts or approximately to that leg. And then finally, you're going to use both leads to test the first and second legs without the neutral to confirm that you have somewhere around 240 volts of electricity. In this case, I have three-phase electric here, so it's less than optimal voltage, but if you get anything much less than 200 volts, chances are you have something wrong with your power cord or the electricity at your house. Check your breaker box and make sure that your breaker's fully reset. Assuming that it's not an electrical issue at your house, we're going to go ahead and start taking the back of this dryer off to access the heat system that will contain all the components that we need. So let's go ahead and speed this up. We're removing about 8 screws from the unit. Here's the entire heat system in a Whirlpool dryer. So let's go ahead and break down the components to understand what they all do and what we're going to have to look at to fix them. Here are the names of each of the components on this Whirlpool or Amana dryer. It's important to pay attention to the names of each one of them, so if any of these fail, that you can order the right component rather than order the wrong one and get stuck with something that you don't need. With this multimeter, we're going to set it to continuity. You can set it to ohms resistance, but this one has a nice little buzzer that makes a loud noise when you know that the component is good, so I'm going to use that on this video. When you're pulling connectors off of a washer, dryer, or any appliance, make sure that you take a photo of where all the wires go when you're done to put them back on correctly. The other thing when testing components, make sure to pull at least one of the spade connectors off. You cannot use your multimeter to test a component with the spades on because it could backfeed through the wiring to get a false positive that the component may be good. The first component being tested is the thermostat. If you touch the probes onto the sensor and you get continuity, the sensor's good. If you get the open loop symbol, the component's bad, and that goes for almost any sensor on an appliance. Next, it's time to test the heating element. Remove the spades from the heating element canister and begin your test with continuity. If you get continuity, it means it's probably good, but you also want to check for ohms resistance and make sure that it returns approximately 10 ohms of resistance, and that may take a few seconds for it to register on your multimeter. In the case of this video, I tested the heating element both with one spade on and both spades off just to check if there are any possible issues, and it turns out it's fine. Next, test to see if the element is grounded out to the canister by placing one probe against a spade terminal on the element and then one to the can itself, the exterior metal housing. This will show you if a wire is loose and hitting the canister itself, and if it is, you get continuity, you need to replace the can immediately. Next up to test is the cycling thermostat. The top and bottom pegs with the red wires are the ones that control the primary heat functions and need tested for continuity, much like the other sensors. These were hard to remove on this unit, but I did it anyway. If you get continuity from these two pegs, you're good. The purple wires on the left and right side are for delicate or lower heat settings. These have to be tested for ohms resistance rather than continuity. A good value on your multimeter depends on the model, but it's usually between 3.6K and 7.2K ohms resistance. If it's drastically outside that range, you'll want to replace it because your heat settings won't work properly. In the case of this unit, I'm getting 7.18 ohms, which is definitely in the acceptable range. Finally, we have the high limit cutoff, sometimes called the thermal fuse. In my experience, this is the most likely component to go out on a dryer. It's a fail-safe device that, should the dryer get too hot, will cause the unit to shut off heat. If you find that this sensor is bad, I highly suggest buying a matching set of both this and the thermostat near the heating element. Sometimes the thermostat will go bad and cause the unit to overheat, blowing the sensor up. This sensor doesn't just randomly die, unlike other sensors on this unit. Additionally, this limit fuse can go bad if you have excessive lint somewhere in the dryer, most likely the blower housing or the vent pipe that goes outside to expel hot air. Make sure to check the blower housing and pipe since you already have the machine opened up anyway. Now, if none of that worked, we're going to take the top of the unit off to check the timer as a last-ditch idea. To make this easier, we're going to flip the console up by inserting the putty knife into the crevice between the chassis and the top of the unit. Take the knife and insert it into the very far side of the console and then press in as hard as you can. It will release the spring that you see now opened up. Do this on both sides of the unit and then roll the top forward, and it will take the console off of the entire dryer, making it much easier to deal with the timer. Next, we're going to take the left harness off. We do not need to remove the right harness. And I'll be honest, this harness is very stiff, so I can't do it with one hand. In order to test the timer to see if it is broken, you need to make sure that the timer is set on a high heat setting. These three contacts are what you're going to need to check for continuity on your dryer to see if the timer is in fact bad. Making sure that it's on high heat, check all three connections for continuity. If you do not get continuity on one of the three, then that means that the timer is bad. It is burnt up. Fortunately, though, I have a video on how to repair these without actually having to spend any money. So if you find that this is in fact the bad part, watch the video and you can fix it at least temporarily for free. If the timer contacts test good, then it means that there may be a loose wire connection or something else affecting the heat on your unit, which it happens but is very rare. Depending on your model, you may have extra modules that could cause the unit not to heat, such as a heat relay on the console or the belt switch, but that varies heavily by model, and I typically see that more on other brand appliances. I'll be putting out more videos on how to diagnose other brands in the near future, so make sure to like and subscribe this channel if you have more appliance questions, or just leave a comment in the comment section and I will see what I can do to help you. Have a great day.